Welcome back to All This Math. This is Professor Parker, and for this lesson, we're going to talk about some math fundamentals. We're going to talk about factors and how to identify factors of numbers and how to list all the factors of numbers, because this is a very important skill that is often overlooked in a lot of educational spaces, and your children definitely need to know how to do this. But before we do that, I want to recognize this t-shirt that I got on. You see it's been through a few rinse cycles because the paint's all chipped up on it, right? This is my Historically Black Colleges and Universities Matter t-shirt. And shout out to the CIAA tournament taking place in Baltimore right now. As I record this video, it's February 23rd, 2023 while I record this video, right? The CIAA tournament is taking place in Baltimore. Check out some of the games if you can. Go down there and spend some money with some Black-owned businesses if you can. There's plenty of them down in Baltimore and around Baltimore. Definitely support that. I also am a product of multiple historically Black colleges and universities. I began my college career at Morehouse College in Atlanta University. I spent 1 year there before transferring to Morgan State University, the national treasure, where I matriculated and earned my bachelor's degree from. Then many years later, after that, in Philadelphia, I earned my master's degree in education from Lincoln University, the Lincoln University. And now currently I teach at Cheyney University, all right, which was formerly the Institute for Colored Youth, when it was founded in 1837 as the first historically Black college university, even though it was technically a high school at that time in 1837 in South Philly. So I'm all HBCU'd out, right? HBCUs, I think, are very important institutions. They have produced a lot of people with different ideologies and different approaches and different politics. Two people that I do want to highlight, in case you're wondering why I got these books in my hand, that are products of historically Black colleges and universities. And it's timely that I mention them today because today these two brothers share a birth date. We have W.E.B. Du Bois, William Edward Burghardt Du Bois, who has influenced my thinking very much over the years. This is one of his many books called Darkwater, a collection of essays. I'm telling you, he got some essays in here. One of them is The Souls of White Folk. And yeah, I mean, it's just a bunch of essays in here. Definitely check this out in addition to his other work. He was born, again, as I think I already said, February 23rd, 1868. And he earned his undergraduate degree from Fisk University in Nashville, Tennessee. So shout out to Du Bois, the ancestor. And also, this is one of many books from another brother who has greatly influenced my thinking and my worldview and my politics, the late Amos Wilson. Amos Wilson was from Hattiesburg, Mississippi, born February 23rd, 1941. I'm pretty sure 1941. So shout out to him. This is one of his books, African-Centered Consciousness versus the New World Order, subtitle, Garveyism in the Age of Globalism. So, and he attended Morehouse College, for his undergraduate, instruction, undergraduate learning, before going on to write extensively, lecture extensively, understand and develop theories in terms of African-centered psychology, that we still benefit from today and that more of us should actually read. So I definitely promote the work of Du Bois. I promote the work of Amos Wilson as a way for us to get out of the mess that we're in. All right. So definitely keep that in mind. Now let's get into the math. Now, listing factors, right? This is essential to having a strong foundation in mathematics generally, knowing what the factors of numbers are. Now, I always talk about how knowing the multiplication facts is very important. What knowing the factors does is a way of organizing the multiplication facts that you know, because what a factor is a number that can be multiplied to make another number, right? For example, two factors of 24 are 6 and 4. 6 and 4 are factors of 24. They are numbers that can be multiplied together to make 24, because 6 times 4 is 24, basically. And different numbers have different factors. Different numbers have different amounts of factors. So I was going over this with a student the other night in a tutoring session, and we were just listing factors, because the sooner you can memorize factors, then the math becomes more fluent. And then the different skills that you'll be introduced later on will come much easier. Now, namely, in case you're wondering, what do I need to know factors for? You definitely need to know factors in order to reduce fractions or simplify fractions, because when you reduce or simplify fractions, you want to find the greatest common factor between the numerator and the denominator. And then you want to divide the numerator and the denominator each by that greatest common factor. So if you know off the top of your head all the factors of all these numbers, let's say you had, I don't know, your fraction was 9/15, and you know off the top of your head all the factors of 9, and you know off the top of your head all the factors of 15. Then all you got to do is say, okay, well, what number is in both lists, right? And what's the biggest number that's also in both lists, right? And you say, okay, boom, that's the number. So I'm going to just divide this 9 by this number. I'm going to divide the 15 by this number. And now my fraction is reduced as much as it can be. And I'll keep it moving, right? But if you don't know your list of factors and you don't know your multiplication facts, then you can't do that. You're going to be sitting in class, sitting there stuck, frustrated, angry, talking about, I hate math, it's too hard. When in fact, it's not too hard. The issue is that you're lacking a certain fundamental skill, or not even a skill really, but you can't practice the skill because you don't have prior knowledge. You need the knowledge of knowing what the factors are for a lot of numbers. All right. That's really what it is. And a lot of students end up caught up in that trick bag where they can't advance because they're missing that fundamental. So that's why I'm making videos like this. So y'all will know this type of stuff and be able to understand, the stuff that you're responsible for in your math classes, right? Another reason that we need to know factors is, let me see, I talked about simplifying and reducing fractions. Also cross-canceling. Yeah, cross-canceling. I almost forgot. Cross-canceling. When you multiply two fractions, or when you're dividing two fractions and then you flip, do the keep, change, flip thing, right? And it becomes a multiplication problem. When you cross-cancel, if you know the greatest common factor between two numbers that are diagonal in relation to each other in their positioning, then you can do the same thing. It's kind of like simplifying a fraction, but you got to know the common factors. So you got to know the factors of each of those numbers to know which number is in both lists. All right. And I'm telling you, if you're a parent watching this video, definitely have your children memorize all the factors. Have them know their multiplication facts from 1 times 1 up to 12 times 12. Have them do that. And actually, don't even stop at 12 times 12. Challenge yourself and challenge them to go up to 15 times 15, right? Even if possible, right? But then also have them to think about, okay, well, what are all the numbers that can multiply together, the whole numbers that is, that can multiply together to equal 9, that can multiply together to equal 15, that can multiply together to equal 14, that can multiply together to equal 27. So really what listing factors does is it provides a way for you to organize all of your multiplication facts into different categories. That's what factors, or a list of factors, really does. And I'm telling you, it will pay huge dividends. I'm trying to tell you. Another reason, another space or area where knowing factors is going to come in handy, when your child gets to either Algebra 1 or Algebra 2, really this should be in Algebra 1, when they learn how to factor quadratic trinomials, right? Factor quadratic trinomials, and they're going to have to know, okay, what are two factors of the constant term that can be added together to equal the coefficient of the linear term, right? A lot of students get caught up with that. They think that's too difficult not because of the algebra, not because of the method, it's because they don't know the factors of numbers. You got to know the factors of numbers. So this is something that you got to learn early on. You got to practice it early and practice it often. All right. Now let's get into it. So what I do with students is I tell them how many factors the number has. So then it becomes an issue of like just filling in the blanks. So 9 has 3 factors, right? And it's another tip that I tell my students. I tell them every number has a factor of 1 and itself. So off the break, you already know 2 of the factors. So with 9, I already know if every number has a factor of 1 in itself, I already know from the rip that my first 2 factors are going to be 1 and 9. Why? Because 1 times 9 equals 9, right? So that's 2. That's a given. That's like a gimme. That's like, the SAT when they spot you those points just for writing your name, as they say, right? So now what's the third factor? We also know that, okay, well, I know that 3 times 3 is 9. So since 3 times 3 is 9, I know 3 is a factor. I don't have to write 3 2 different times because it's the same number, even though 3 times 3 equals 9. It's just one number that's being multiplied to make 9. All right. Now 15. Again, every number has 1 and itself as a factor. So we got 1 and 15. All right. 1 and 15. And then what else? We got 5 times 3. And again, if your child is attempting to do this, you should be thinking about, okay, where do I see 15 at in the multiplication table? Not on the edges, not across the top row, not across the side row, the side vertical column, but inside the multiplication table. Where do I see 15 at? And what two numbers multiply together to make 15, right? What pairs of numbers? That's what your factors are going to be. So then we got 5 and we got 3. All right. Then with 14, we got the 1 and we got the 14. Other two factors of 14 are 7 and 2, because 7 times 2 is 14. All right. 7 and 2. All right. 16. Again, 1 and itself. So you got 1 and you got 16. All right. What else we got? 8 times 2. 8 times 2 is 16. We know our fact. Now, here's another thing, too. You don't have to do it this way, but I'm telling you, it'll help you, especially because later on, when you get to factoring quadratic trinomials in algebra, you're going to want pairs. You're going to want factor pairs, numbers that can multiply together by each other to equal a certain number and also add up to a certain number, right? So some people they list the numbers in numerical order. They would do like 1, 2, and 4, because 4 is the other factor of 16, because 4 times 4 is 16, right? So they would do 1, 2, 4, then 8, then 16. Personally, I don't like that. It's not wrong, but I don't like it. You know what I'm saying? Like, that's not my thing. I like to have the numbers organized by pairs. So students can look and say, all right, well, I know 1 times 16 is 16. I know 8 times 2 is 16. And I know 4 times 4 is 16. So like when they visualize it, it's like they're memorizing not just what the factors are, but what the factor pairs are. You know what I'm saying? Kind of like with shoes, right? When you go on a trip, you pack your shoes, you pack a couple pair of shoes, you're going to put the left shoe with the right shoe. Boom, that's one pair. Then you put the left shoe with the right shoe. Boom, that's another pair. Then you put the left shoe with the right shoe. Boom, that's another pair. I don't know a lot of people. I mean, you might do this, but if you're watching this video, I don't know a lot of people that if they packing 3 pairs of shoes, they're going to pack 3 left shoes, throw them in the bag, and then take 3 right shoes and then throw them in the bag. I don't know. Like, maybe you get down like that. I don't know. But that's how I approach listing factors. I like to do the pairs of numbers, because 1 times 16 equals 16. But if you list them in order, right, you would do 1 and then 2, right? Or even whatever numbers come to mind, right? You might do 1 and then 2, but 1 times 2 don't equal 16, right? Now, hopefully you will put the 8 still, and hopefully you still put the 16, right? But like I said, and it's not wrong. That's what I'm saying. Like, that's another thing. It's a preference, right? But I suggest for students, so that they're constantly thinking about the pairs of numbers that go together, right? I always suggest, like, list them in pairs. So that way you get used to seeing the pairs of factors. All right. Now we get to 20. I didn't put the spaces, but anyway, 20, just like anything else, itself and 1, itself and 1, itself and 1 are factors of every number, right? And then what else? What else we got? We got 20 is an even number. So another tip that I'll give you is this. Every even number has a factor of 2. So now you should be thinking, oh, well, 2 times what equals 20? 2 times 10. So you got your 2 and you got your 10. And then what else? 4 times 5. So 4 and 5. All right? 4 and 5. Let me slide this 36 over. It's a little crowded over here. All right, now 21. 21 and 1. That's 2 factors. Boom. What else? 7 and 3. Boom. Nothing else. 21 and 1, 7 and 3. Now, what happens if you have a number that only has 2 factors, 1 and itself? That's called a prime number. There's a special word for that. Those are prime numbers. All these numbers that have more than 2 factors, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6 actually. These are called composite numbers. Composite numbers. So prime versus composite. Composite numbers have multiple factors, right? But not an infinite number of factors. I learned that recently. Whereas prime numbers only have 2 factors. All right. So prime got 2. Composite numbers have many. All right. More than 2, basically. 22, we got 22 times 1, and we got 11 times 2, right? So these are the list of factors, all right? And again, you see a parallel between like math and, our general existence. When we talk about like, what are the contributing factors to a situation? Like, what are the contributing factors to a problem? What are the contributing factors to something that is good, something that we enjoy, something that we like? What are the contributing factors, right? These are the numbers that contribute to creating 20, right? 20 times 1 contributes to creating 20 because 20 and 1, or 20 times 1, like I said, equals 20. 2 times 10 contribute to making 20 because 2 times 10 equals 20, right? Contributing factors. So what you want to do, another thing you can do with math is think about words that you know just generally from the English language and how you use them in a certain context. And then that'll help you to remember what they mean in mathematics, right? They may not mean the exact same thing, but the meanings are still going to be similar. At a minimum, they're going to be similar. Even that, the word similar. When we get into geometry, we talk about similar triangles, similar polygons, things that look the same, but don't have the exact same dimensions necessarily, but they're similar, right? They're not exactly the same. They're not congruent, but there's a scale factor involved, and one may be a smaller version or a larger version of the other, but they're similar, right? All right, so now 27, we got 27 and 1, then we got 3 and 9, and that's it. 4 factors. 30 got a bunch of them. So 30, we got 30 and 1. I got 3 and 10. Well, I left out 2. A lot of people don't know because 30 is a larger number, right? 30 is a larger number, and the 12 by 12 multiplication table doesn't go up this high, but 2 times 15 is also equal to 30. 2 times 15 will also contribute to giving you 30, right? 2 times 15 will give you 30, all right? And then 6 times 5. All right, 6 times 5 is giving you 30. Now, again, if you know your multiplication facts, this really should be a relatively easy exercise. But listing factors is a way to organize what you know about your multiplication facts. It's a way to organize and categorize your multiplication facts. All right, 32. We got 1 and 32. We got 2 and 16. This is a lot of students don't know this either because the multiplication table that goes up to 144, 12 times 12, it doesn't go up to 16. So the 16 facts won't be on there, right? So 2 and 16, 3 is not a factor of 32. 4 is a factor of 32. 4 times 8, that'll work. 5, 6, yeah, that's it. 1 and 32, 2 and 16, 4 times 8. Yeah, that's it. That's it. 6 factors. 35. 1 and 35, and 7 times 5. Any number that ends in 5 has a factor of 5. All right. Any number that ends in 0 has a factor of 5 and 10. All right. Any number that ends in 0 has a factor of 5 and 10. All right. Just some math tricks. These are just some of the cheat codes I'm giving you. All right. 36. You got 1 and 36. This is another one that's not as popular. Not as many people know this. 2 times 18. 2 times 18. 2 times 18. Try to memorize that. The factors of 36. 2 and 18 are 2 of the factors of 36. Then we got 3 times 12. If you know your 12 facts, then you would know that 3 and 12 are factors of 36. Because 3 times 12 is 36, and 12 times 3 is 36, likewise. All right. What else we got? 4. 4 times 9 is 36. All right. And last but not least, remember, 36 is a perfect square. Why is it a perfect square? It's a perfect square because there's a whole number that can be multiplied by itself to equal 36. That whole number is 6. 6 times 6 equals 36. And that's also on the multiplication table that goes up to 144. So 36 has 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 factors. All right. Now, also, factors are whole numbers. Factors are whole numbers. Okay. Now, there's an infinite number, for example. There's an infinite number of numbers that will multiply together and make 9. But most of those numbers are not whole numbers. Like if you can multiply, like it's a bunch of decimals that can multiply together and equal 9, approximately, but they're not whole numbers. So when we speak of factors, we're talking about whole numbers, 1, 9, and 3. 1, 9, and 3. Actually, wait a minute. Let me think about that. Maybe we're talking about integers. I need to look into that because maybe... Yeah, I need to look into that because I'm not sure if -1, -9, and -3 are also considered factors of +9. I'm not sure, but that's what I call a mathematical nuance. That's like a detail, right? That doesn't really affect the work that we did here. this in terms of fundamentals, I want your children, if you're a parent watching this, or if you're a student, this is directed at you. If you're a parent, this is directed at you too. If you're a teacher, it's directed at you too. Just to understand how to organize the multiplication facts that they know into lists, into convenient lists. All right. The factors of 9, factors of 15, 14, 16, 20, 21, 22, and so on. And they should be able to do this for any number. All right. At least from 1 to 100. So what I'm starting to advocate now is that in addition to students knowing their multiplication facts, at a minimum from 1 times 1 up to 12 times 12, be able to list all the factors of every number from 1 to 100. Every number from 1 to 100. Just list them and have them memorized. All the factors. I'm telling you, it's going to pay dividends. It's going to pay dividends down the road. Because once you know them factors, then you can start, like, when you get to the algebra, you get to the more complex work, it's going to come to you much more quickly. All right. And when you're out in the world doing everyday math, you're going to understand relationships between numbers and different quantities and amounts. Right. So I definitely advocate for that. So definitely have your children, have your students, start memorizing the list of factors from 1 up to 100. Also, quick little thing. Let me say this too. The number 1 is neither prime nor composite, because it doesn't fit. You would think it's a prime number, but it don't fit the definition of a prime number, because prime numbers all have 2 factors and 1 only has 1 factor itself, because 1 times 1 is 1. All right. So 1 is in a class all by itself. 1 is special. All right. So you got prime numbers. They got 2 factors. Composite numbers have more than 2 factors, right? But not an infinite number of factors, right? And 1 is neither prime nor composite. All right. So practice your multiplication facts. Practice listing the factors of all numbers. And shout out to the HBCUs. And I'll see you on the next video. Peace.